A very good day to Madam Chanuri and to the viewers. My name is Namanida Analalaki Raj and my metric ID is 211291020. Today we'll be discussing about amplifiers. In this experiment, we will be looking at 5 types of amplifiers. The first amplifier is inverting amplifier. Inverting amplifier is used as trans-resistance amplifier. Second amplifier is non-inverting amplifier and used when high input impedance is necessary. Third amplifier is summing amplifier, which is used to combine the voltages present on two or more inputs into a single output voltage. Fourth amplifier is integrator amplifier and used in calculus operations in analog computers, ramp generators, and wave shaping circuits. Lastly, the amplifier is differentiator amplifier, which is used to suppress noise. Now let's move on to the circuit constructed in LT-Spice, and we'll be discussing it further. Well, now we will be looking at inverting amplifier circuit. So this circuit consists of 3 power sources, V1, V2 and V3 here. So, and the R1 is 1 kilo ohm, the R2 is 33 kilo ohm, and this is the amplifier. The V in is here, the V out is here. As for V1, it is sine based and has the value of 0, 1 and 1 kilo. And for V2 is 15 volt, and for V3 is 15 volt as well. And we have 3 ground, 1, 2 and 3. And for this circuit, I've used the command whereby it is point trend 0, 100 milli, 50 milli and 10 micro. So now let's look at the first waveform. The first waveform is V in. The waveform ranges from 1.0 volt to negative 1.0 volt. And for the second waveform, we'll be looking at IV1. It ranges from 450 microampere to negative 450 microampere. For IV2, the value ranges from negative 2.00 milliampere to negative 2.48 milliampere. And for IV3, the value is the same, which is negative 2.00 milliampere to negative 2.48 milliampere. And for the last waveform, which is the V out, it is 15 volt to negative 15 volt. And for inverting amplifier, the output of this amplifier will invert the waveform like positive magnitude wave and will show the amplified negative magnitude, or vice versa. For example, the sine wave as input will look like an amplified cosine wave. Now we'll be looking at the non-inverting amplifier circuit. This circuit consists of 3 power sources as well, V1 here, V2 here and V3 here. The V1 is sine based power source, which has the value of 0, 1 and 1k. The V2 here has 15 volt and the V3 here has 15 volt as well. This circuit consists of 2 ground, 1 here and 1 here. The V in is here, V out is here. This is the amplifier. This is the resistor, which has the value of 1 kilo ohms, and this is resistor 2, which has the value of 10 kilo ohms. And for this circuit, I have used the command point trend 0, 100 amp, 50 amp and 10 micro. So now let's look at the first waveform, which is the V in. For V in, the value ranges from negative 360 millivolt to negative 396 millivolt. Now let's look at IV1. For this waveform, we're looking at 0.8 milliampere to negative 1.4 milliampere. Now we'll be looking at IV2, which is negative 1.6 milliampere to negative 2.6 milliampere. Now we'll be looking at IV3, which is negative 1.9 milliampere to negative 3.0 milliampere. And lastly, we'll be looking at V out, which ranges from 8 volt to negative 14 volt. And as for this waveform, which is non-inverting amplifier, the input V in and output V out voltages are within phase through each other, so their phase difference is 0 degrees or 360 degrees. So the positive sign specifies that there is no phase shift between the input and output. The voltage gain is dependent on two resistance, which is R1 and RF. Now we will be looking at the summing amplifier circuit. This circuit has three power sources as well. The first one is sine based, V1 here, which has the value of 0, 1, 300, V2 15 volt, V3 15 volt, and there are two amplifiers, U2 here and U1 here. There is R1 resistor which has the value of 2 kilo ohms, R2 with 2 kilo ohms, and RF with 10 kilo ohms. The V out is here and the V in is here. For this circuit, I've used the command which is point trend 0, 100M, 50M, and 10U. So for the first waveform, we'll be looking at V in. For V in, the value ranges from 1 volt to negative 1.0 volt. So for IV1, the value ranges from 500 microampere to negative 500 microampere. For IV2, the value ranges from negative 4.25 milliampere to negative 4.80 milliampere. For IV3, the value ranges from negative 4.25 milliampere to negative 4.80 milliampere. And for the last one, which is V out, the value ranges from 10 volt to negative 10 volt. So for this summing amplifier, the summing amplifier produces a voltage output that is equivalent to an amplified sum of two or more input voltages. Usually, a summing amplifier is in fact an inverting amplifier, which means the output voltage has a negative value when measured to ground. So this is the integrated amplifier circuit. This circuit has three power sources as well. V1 here, which has the 15 volts, V2 here, which has 15 volt as well, V3 here, which is pulse based, which has the value of negative 1, 1, 0, 0, 0, and 100U and 200U. V in is here, V out is here. The amplifier U1 has one capacitor with the value of 0.01 micro. Then R1 here, which has the value of 100K, and RF, which has the value of 10M. And for this, I've used the command which is point trend 5M. Now we'll be looking at the first waveform, which is V in, which has a value of 1.0 volt to negative 1.0 volt. Now we'll be looking at the second one, which is IV1. The value ranges from negative 2.236 milliampere to negative 2.256 milliampere. And now we'll be looking at the third one, which is IV2, with a value of negative 2.244 milliampere to negative 2.264 milliampere. Now we'll be looking at the fourth one, which is IV3, with a value of 12 microampere to negative 21 microampere. And for the last one, we'll be looking at V out, which is 14.10 volt to 13.74 volt. As for integrated amplifier, if the square wave is provided as an input to integrated amplifier, the produced output will be a triangular wave or sawtooth wave. In such cases, the circuit is called a ramp generator. In square wave, the voltage levels change from low to high or high to low, which makes the capacitor gets charged or discharged. And as for the square waveform. This is due to the usage of pulse power source. So this is the differentiator amplifier circuit. This circuit consists of 3 power sources as well. V1 here, which has 15 volt, V2 here, which has 15 volt, and V3 here, which is pulse based, which has the value of negative 1, 1, 0, 0, 0, 100 micro and 200 micro. This circuit has 3 grounds, ground 1, ground 2, ground 3, and has R1 which has 1 kilo ohms, RF 100 kilo ohms, capacitor 1 0.01 micro, capacitor 2 which has 100 P, and V out is here, V in is here, and for this I've used the command point trend 5M. Now we'll be looking at the first waveform, which is V in. The value ranges from 1.0 volt to negative 1.0 volt. And for the next one, we'll be looking at IV1, which is negative 2.16 milliampere to negative 2.31 milliampere. And as for the third one, we'll be looking at IV2, which is negative 2.19 milliampere to negative 2.34 milliampere. And as for IV3, the value ranges from 160 microampere to negative 280 microampere. And for the last one, we're looking at V out, whereby the value ranges from 10 volt to negative 16 volt. And as for differentiator amplifier circuit, the differentiator circuit outputs the derivative of the input signal over a frequency range based on the circuit time constant and the bandwidth of the amplifier. The input signal is applied to the inverting input, so the output is inverted relative to the polarity of the input signal. I guess that sums up this video. Thank you for watching.